This is the board we are using for the LED IV characteristics as part of laboratory experiment. Coming to this is a variable power supply. It can give the voltage in between the 0 to 10 volt DC. The connections are given to the here this is a positive terminal and it is a negative terminal. And going like this is the resistor connection. Resistor, we have different connections like 1K, 2K, 3K, 4K. Based on the requirement, we can select any one of the resistor here. After the connection of after the resistor connections, so this is the ammeter connections. So this ammeter gives the value related to the how much current is flowing through the LED. This is ammeter positive and ammeter negative. External ammeter is connected here, and here this is the LED connections. So generally we are giving direct LED connections here, but instead if you want to check the red LED, blue LED, yellow LED, green LED IV characteristics, we need to choose. If you want to red LED is connected to here, and the same across the LED we want to check the voltage, so then voltmeter is also connected across the LED. As we know that, so ammeter is connected in series connection and voltmeter is connected in parallel way, so that ammeter gives the current value in a particular circuit and voltmeter gives the voltage across a particular component, and the other end is connected to the this battery. And coming to the connections point of view, this is the ammeter. The range is 20 milliamps. That means it can able to measure up to the 20 milliamps range. This is the positive connection and the negative connection. Coming to this is the voltmeter. Here we have taken the power sources like 0 to 10 volt DC. To measure that, we are taking the voltmeter with range is 20 volt, and this is a positive connection and it is the negative connection. And this is a circuit board what we are using for the measurement. And coming to the connections point of view, first this power supply need to connect to the power supply location. To show the difference between the positive and negative, positive we are take it as like a red Y. This positive connection, positive of the DC power supply is given to the positive of the circuit, and negative of the circuit is given with black color Y, and this is the negative. Now we successfully give the battery connections to the circuit. Coming to the resistor point of view, we don't have the positive and negative difference. That's what I just taken the two same color wires, and I have chosen 1 kilo resistor. Now for the circuit, resistor connection is also over. Coming to the ammeter, this is an external device. Ammeter, the positive. Ammeter positive is gives to the this is ammeter positive. Ammeter positive is gives to the ammeter positive, and then ammeter negative is connected to the ammeter negative. So now the ammeter connection is also over. And coming to the LED point of view, LED is light emitting diode. It's a simple p-n junction diode connected in forward bias. So now I want to choose the LED with red color. That is, now I am going to measure the red color LED IV characteristics. See here, I just chosen the LED. Now I want to measure the voltage across the LED. For this, I just taken the cross like a parallel, the common point for the external device like voltmeter. This is a common, and we are given the voltmeter negative. See here, these are the common points, and we are given the voltmeter positive to the LED positive and voltmeter negative to the LED negative. So see here, the connections are O. Battery to the battery, resistor to the resistor, ammeter to the external device ammeter, and LED with red LED, and at the same time LED parallelly connected with the voltmeter, so that now we can able to measure the current through the LED and voltage across the LED. This information gives the IV characteristics of the LED. Now this is the time to on the circuit. This is the power button. This is the external connections. See here, initially these two readings are 0 and 0. That means that we are not supplying any voltage and we are not getting any current. And this is the power source button. Now first turn on the circuit. Now slowly increase the voltage now, because this is a variable voltage source. Now slowly increase the voltage. Now you can see the value change in the voltmeter. Now it is 0.43 value, but the current value is 0. This is the current and this is the voltmeter. Just note down the values of the voltage and the current. See here, this is the observation. First, serial number 1. Initially the voltage is 0 and the current is 0. Serial number. Now I have observed that the voltage is 0.43 but the current is 0. Slowly raise the knob value and observe the current and voltmeter values. Now it is 0.95 and the current is 0. And again, one more thing you should observe here, whatever the LED you selected here, whatever the LED you have selected, it's not glowing. That means that the current is not passing through the LED. You just see the current values and the voltage values here. 1.25, even the current is 0. 1.34, the current is 0. 1.40, the current is 0. And 1.47, the current is 0. 1.56, the current is 0. 1.60. Now you see the difference. Here the current is 0.1. Now the current starts to rise. See here, 1.62 or 66, 0.04. Now you just observe the LED here. Slowly it is glowing. Slowly it is glowing. See, still I am increasing the voltage by using the power supply. Now it is 1.71, 0.1. 13. You can clearly see the difference here. LED is glowing with brighter intensity. Now I just increase the current value 1.75, 0.32 is the reading, 1.78, 0.58. You can see the difference. It's glowing, that means the brightness of the LED is increases. 1.80, 0.81. Still I am increasing the value. 1.83, 1.33 is the current. 1.85, 1.80 is the current. 1.87, 2.34. Now you can see the difference. The voltage increment is very minute, but the current increment is very high. 1.88, 2.76. You can see clearly the intensity is increases. Now 1.89, 3.02, 1.90, 3.43, 1.91, 4, 1.92, 4.54, 1.94, 5.27, 1.95, 5.92, 1.97, 6.82, 1.99, 7.63. So this is about the current and voltage. You can see here, you may get doubt. Here it is a 0 to 10 volt DC. Now I completely given the voltage here, but here the reading is limited up to 1.99. Why? We are supplying as input as 10 volt, but we are getting only around 2 volt here, because here this voltage is not the input voltage. This voltage is the voltage drop across the LED, voltage across the LED, because the voltage is parallel components point of view, it's split. Sorry, series is the resistor and the LED is both are in series. Some voltage may drop at resistor, some voltage is dropping at LED. Now we are using the measurement related to the LED voltage by giving the parallel connections to the LED. This data is related to the IV characteristics of the red LED. And if you want to check with the blue LED, see here, just I will turn off the power supply and reduce the voltage. Now I just change the selection of LED here. Now I choose in the other LED. Now again the process is same. It starts with the 0 0 and initially it's a starting point. We just need to rise the voltage. See here. Now the another LED point of view. Previously in case of red point of view, when it reached to the 1.6, we can able to observe some current value. But here it is other LED point of view. Even we are applying the 1.62, the current there is no change. Even I just increase till 1.95, the current value is 0 only, because the voltage at which the current starts to rise is completely decided by the material what we are using for the construction of the LED. Red LED material is not same as blue LED, and blue LED is not same as yellow. Here it is 2.43. See here, slightly 1.9891, 2.10, 2.22, the current is 0. But once it reached to the 2.4 around, the current starts to rise. 2.4 around, the current starts to rise. Similarly, we just guess the values of different thing. 2.43, 0.12, 2.48, 0.40, 2.51, 0.88, 2.54, 1.40. You can see the difference here. Here we are selecting the blue LED. That's what the IV characteristic of blue LED is different compared to the other LED. Now it is 2.57. The current value is 1.93. Here it is 2.75 is the current and 2.59 is the voltage. 2.62 is the voltage and 3.40 is the current value. 2.65, 4.53, 2.71, 6.68, 2.72, 7.38. Similarly, if you want to go for the green LED, the power connections need to be changed like this. You should remove the LED connections, and now I given to the green LED. Again, the power on. See here, now green LED is activated. Initially, with the lower voltage, there is no glow, but once it reaches to the threshold voltage, it starts to glow, and with increasing the further voltage, the current is increases, and then the intensity of the green LED also increases. You can observe here, it slowly changes the intensity parameters. See here. So this is about the LED connections and the LED IV characteristics. By using this circuit, we can able to measure the threshold voltage and dynamic resistance by taking the graph in between the voltage as x-axis parameter and current is y-axis parameter. The procedure to draw the graph and to measure the threshold voltage and dynamic resistor is as follows. Coming to the measured values of voltage and the current. See here, this is the measured values related to the red LED. This column is related to the voltage and this column is related to the current. 0, 0, 0.430 like this up to particular value, it's showing the 0, and then these values are increases. Similarly, we have measured the values for the blue color light. This is also the same procedure, but you can see the difference. Here the current starts from the 0.60, but here the current starts from the 2.34 value. So now I have to take the graph paper. This graph taken the x-axis is taken the voltage parameters in terms of voltage, and y-axis is take it as the current in terms of milliamp. Here the milliamps, milli means 10 power minus 3. As we know that LED stands for the light emitting diode, and the construction point of view, LED is a simple p-n junction diode operated in forward bias. The forward bias, the current is milliamps. If it is any device is operated in reverse bias, then we take it as the units for microamps. Here the milliamps relate to the PN junction diode operate in the forward bias. And voltage, we have the first we need to check the values. The highest value is 2.72 for the blue LED and 2 is around 7.63. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 columns. If each column is divided with the 0.2, then its significance is related to the 0, 0.2, 0.4 like this, 3.6 we may able to draw. That means, so the values, all values can able to accommodate. 0.4, 0.6, 0.8, here it is 1, 1.2, 1.4, 1.6, 1.8, it is 2, 2.2, 2.4, 2.6, 2.8 and this is the 3. These are the values we need to consider. Similarly, y-axis is around like a 7. So we have different values, right? I just take it the 0.5 is the difference. Then we can accommodate with 14 or the 15 columns. It may go up to the 7.63. So y-axis, I just divide the column like 0.5, then 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, this is the 7.5 and it is the 8. Now, we have different values, right? First I just take the red. 0 is for 0. 0 and it is 0. I just consider the 0 on x-axis and 0 on the y-axis. The current is also 0. 0.2 value, again it is 0. 0.4 is 0. Like this, we are getting up to 1.6. This is 1.6 is around 0 and 1.66. This value is 0.04. This is 1.4, 1.6 and 1.66. So like this, we are able to get the value like 0.04. Similarly, we have to draw all the points in the graph paper and then we need to join the points. This is about the points related to the red LED. So just join all these points. This is about the IV characteristics related to the red LED, and the threshold voltage is nothing but, just see here, the point where the current starts to rise, that point is take it as the threshold voltage. Dynamic resistance is nothing but the slope of this line is related to the dynamic resistance. This is about the IV characteristics curve related to the red LED. Similarly, when we draw the blue curve, the diagram is like this. Similarly, for the blue point of view, see here, these star points are related to the blue. When we join all these points, see here the diagram. This is a curve related to the blue IV character. Clearly we can see that red LED threshold voltage value is lower compared to the blue LED threshold value. So this clearly signifies that blue need more threshold value. Threshold value is more compared to the red threshold value, because blue color LED have more energy gap value compared to the red, because energy gap Eg is nothing but h nu, which is equivalent to hc by lambda. For the red LED, lambda value is more, because of that Eg of red is less than Eg of blue. Then because of the higher energy gap, it requires more threshold value to move the charge carrier from the lower valency band to the conduction band. Because of that, the current can able to give in blue LED with more threshold value of the applied voltage compared to the red. Similarly, we can check for different kinds of LED. This is about the LED IV characteristics for two different colors. Similarly, we can choose for any kind of color. Thank you. I hope you have enough knowledge related to the LED by seeing this video. Hope it might be useful for your laboratory experiment. Thank you.